Hello students. So today we are going to discuss a very important topic of the 12th class physics. Though this topic is very basic because you have studied a lot of time of this topic in your junior classes also this topic is taught in your 12th class it is taught. But it is actually very important. Why it is very important? Because every year in NEET, in JEE mains, even in JEE advanced, the questions are asked based on the concept of this topic. So, without wasting a time, let me reveal the topic I'm going to discuss today is the Coulomb's law. I know that you must be thinking that this topic we have studied lot many times. Yeah, I know, but still there are lot many things which need to be considered. And as I told that this is very important topic because every year you can find the question based on this topic. Okay, as you know already, let me just give you a brief idea about this topic, what exactly it is. Then we will solve some quality questions based on that, so that we will have a crystal clear approach that how exactly we can use this particular concept in the question solving. Okay, so you know that whenever there are 2 point charges, let's say this is Q1 and Q2, if it is placed and they have the distance between them is r. Okay, so whenever the 2 point charges are placed or are separated by a distance r, then there is a force between them, the electrostatic force of attraction or repulsion. Based on that, the nature of the charge, we know that the like charges repel each other, whereas the unlike charges attract each other. Okay, so Coulomb gave a relation, and he said that the force between these two charges is actually basically directly proportional to the magnitude of the charges and is inversely proportional to the square of the distance between them. When you club them, it comes out to be Q1 Q2 over R square. And when you remove this proportionality sign, we have this F equals K times Q1 Q2 over R square. Okay, now this K is called proportionality constant, and here the value of K is 1 over 4 pi epsilon naught. When you solve this, it comes out to be 9 into 10 to the power 9. Okay, now the thing is, see, this force is actually the relation between the forces k q1 q2 over r square, where k is 1 over 4 pi epsilon naught. Okay, here epsilon naught is actually kind of important thing. Why it is so important? Because epsilon naught is called permittivity of free space. Okay, this is called permittivity of free space. And actually, see, the permittivity is some bit complex to here, but it is not that much complex. Permittivity of any medium is basically, you can say that the polarizing power of that medium means whenever an external electric field is applied in that medium, so how much that medium is polarized, we can, judge by this, knowing the permittivity of that medium. Okay, so we can say that higher the permittivity of the medium, higher the polarizing nature of that medium will be. Okay, so this is 1 over 4 pi epsilon naught. Okay, now the thing is why I'm saying so that the permittivity is actually very important, because many a times they have asked the dimensional formula of the permittivity. Okay, so you should be knowing that the permittivity comes in which particular relation, so that you can find the dimensional formula. And apart from that, the value of the permittivity is 8.85 into 10 to the power negative 12. You can derive the unit from here. It is basically, we can say that Coulomb, uh, Newton, like this. Why so? Because from here you can derive the unit. Okay, it is quite easy. It is not a tough task to find out. Okay, now the important thing is that what if the medium is not free space, vacuum, or air? You can say that. Okay, what if the medium is not air? What if the means we have some other medium? In that case, this formula is changed into F equals 1 over 4 pi epsilon naught times epsilon r. Okay, Q1 Q2 over r square. Okay, now this epsilon r is nothing but the permittivity of that medium. Okay, sometimes it is represented by K also, which is called dielectric. Okay, so permittivity of that medium or dielectric, we can use the terms interchangeably. There is no difference between them. So you just have to remember one thing, that whenever there is a medium, you are supposed to multiply it by its permittivity or the dielectric. Okay, now this concept is actually very important. Why so? Because just recently in this 2023 JEE Mains, this question was asked. The question was somewhat like this. Let me illustrate the question. Okay. The question says that we have two charges, okay, Q1 and Q2, placed in a medium, okay, with let's say with some distance d. It is already placed in the medium having the dielectric constant K. Okay, now they are saying that if the same two charges are placed in the air, what will be the new distance so that the force between them remains same? Okay, are you getting what I'm saying? Means what they are saying is that if they are placed in some medium and separated by distance d, let us assume that they are having some force F. Okay, so they are asking that now if we put this system into air with the means with the same force, then what should be the distance between them so that the force does not change? Okay, so now we can say that we just studied that force is nothing but 1 over 4 pi epsilon naught times, now this times epsilon r will be written by k, okay, and the distance and q1 q2 over d square. This is the formula for, means when the charge are placed in some medium. Okay, now when you put this system into the air, so you know that in that case they have already mentioned that the force must not change. Okay, so we are not changing the force, so in that case 1 over 4 pi epsilon naught only, q1 q2 over, now this times the distance will be somewhat different, so let us represent it by d, capital D, okay, capital T square. So we just need to find that what should be the value of capital T in terms of other parameters which are given to us. So if you compare these two equations, you can easily write 1 over 4 pi epsilon naught k q1 q2 over d square will be equals to 1 over 4 pi epsilon naught q1 q2 over d square. So most of the things will get cancelled out. You can see from here. Okay, so here we are left with d square equals k times d square, or capital D is nothing but root k times t. Yes. So the new distance will be nothing but the root k times of the original distance which was given, and this was one of the options. It was given in means the option. Okay, so this was the recent question which was asked in JEE Mains 2023. So you can easily see that how the questions are framed and how easy if you know the concept properly. Okay, now let me tell you one more thing. Means this was also asked in this JEE in 2023. Okay, let us assume that we have two charges. Okay, they have the equal magnitude and they are separated by two a distance. Okay, now what exactly they were asking, that if we place a test charge at its equatorial plane, okay, test charge, let's say that the test charge is q naught. Now they are asking that what should be the maximum value, so that this maximum value so that this test charge experiences the maximum force. Okay, and it was written like in this form, and they were asking that what should be the value of x in this case. Okay, now you know that this is very standard result. If you remember it, you can easily write it that the maximum distance we will be observing here will be a by root 2. But even if you do not know, we can easily find it out by resolving the vectors. You know that this positive charge will be applying the force in this direction. Likewise, this will be applying the force in this direction. Okay, now, if we just go through the symmetry, we know that this is y. Now, since the magnitude of the charges are equal and the distance between them is also identical, so you can easily separate out the things by the symmetry. So the distance between the charges will be nothing but a square plus y square, the root. Okay. Now, if we consider that this angle is theta, okay, so again by symmetry you can easily see that if you resolve the vector, then you will be having cos component in vertical direction of both the vectors. So these two components will be added up, whereas the sine component, which will be here, these sine components will get cancelled out. So the force expression will be nothing but F equals K times Q naught over R square, which is A square plus Y square. So as I told you, this is the one force, okay. But as I told you that the cos component will get it up, so the net force will be 2 times F cos theta. Okay. So if we put the respective values, 2 times F is Q naught over A square plus Y square. And if you look upon the cos theta, it is actually y over a square plus y square power 1 by 2. Okay. Now you need to maximize this force. Okay. You need to maximize this force. So we know that whenever we have to maximize a function, what you do is you differentiate and put it equals to 0. Okay. So now you have got this function. This function you need to differentiate, though it is looking a bit tidy, but it is actually not that much. Okay. If you wish, I can solve it for you also. See, we just need to focus on this part. Okay, so rest of the things we will not be thinking. So what exactly we have to maximize is, or we have to differentiate is this thing. A square plus y square is to power 3 by 2. So you can easily differentiate by applying u over the v rule, and you will come to know that this y is coming out as a over root 2. Okay. Now if you compare it with this, you can easily say that my x will be nothing but 2 in this case. And this question was asked in JEE Mains 2023. Very recently, this question was asked. Okay, so these type of basic questions are asked in JEE Mains. Okay, though some of the advanced questions we will be discussing here also. But what I'm trying to say by this is that this particular concept, that's the Coulomb force, is actually very important. Though it is very basic, we have studied not many times, but still students find it difficult to apply when the actual problem comes. Okay, so you should be having the crystal clear concept what exactly the thing is and how we are going to apply it. Now let us take some classic problems based on Newton, this Coulomb's force. Okay, now this time we are going to mix the mechanics with this. Okay, so this is the habit of JEE means that they most of the time mix the different concepts and they ask a question. Okay, and the mechanics is one of their favorite topics for sure. So what exactly the question is, we just assume a system. Okay, we have a spring mass system like this. Now these two are the metallic masses, and the spring itself is a metallic spring. Okay, so they have the mass m, and the spring has a spring constant k. Okay, the spring constant is k. Now, what they are saying is that you are giving this system a positive q charge. Okay, so what exactly you are going to do is you are giving the system a q charge. Okay, so now the q charge is given to the system, so definitely the system is going to have electrostatic force between them. Okay, so what exactly the things are going to change now is, now they the question is that what should be the value of q in terms of the given parameters. Okay, at the equilibrium position. Okay, after the means the equilibrium is reached, what should be the value of q in terms of the given parameter. So how we are going to deal with this question is, now see, whenever you are going to give this charge, so by symmetry we can say that this charge will be distributed like this. Means it will be having q by 2 charge, it will be having q by 2 charge. By the conduction method, we can assume that this is the complete system. So by symmetry, the means the left hand side will be the left hand mass will be having the half of the charge, and the right side mass will be having the half of the charge. Okay, though you have given the total charge q, but it will redistribute itself in this fashion. This is the method of conduction. See, method of conduction itself is very important topic. Why important? It is very basic topic again, but again the questions are asked even in 2023 JEE mains. The question was asked based on this method of conduction, so we will quickly be looking upon that. What is method of conduction after just solving this question, so that you have a better picture, so how exactly the things are working in this case. Okay, fine. Now see, initially it has this length as, let's say, original length L naught. Okay. Now the charge has come into the play. So let's say that the new length becomes is L. Okay. After the repulsion and all these things, the equilibrium is reached, and we assume that the new stressed length is L. Why stressed length? Because the repulsion will be there, because these two are the like charges. Okay. Now at equilibrium position, particularly if we draw the FBD of any of the mass, what exactly will be happening? The spring, let's say I'm making the FBD of this left hand side mass, this mass. Okay, so I can assume that in this particular case at equilibrium, what will be happening? The spring will be, pushing this, particularly pulling this block towards right, whereas there will be an electrostatic force of repulsion between them. So at equilibrium, these two forces will be balanced out. So we can write an equation like KQ1 by KQ1 Q2 over the distance between them, that is L square. Okay, that should be equals to the spring force, and spring force is K times what? L? No, it will be K times L minus L naught. Why K times L minus L naught? Because the spring force is K times X, where X is taken as the distance from the mean position. Mean position means the relaxed state. Okay, so at particular means at in this initial case, it was having the unstressed length as L naught. Okay, so the extra length which has been stressed is actually L minus L naught. So we will be taking this. Okay, so now if we just solve it, so what exactly the things are going to here? See, one more thing we need to see that these k and this k are not the same. So for the sake of simplicity, let me write it as k dash so that you do not get confused. Okay, now let us put the values. So here it comes out to be 1 over 4 pi epsilon naught q square times, here again it is 4 L square, that is k times L minus L naught. So if you solve this, you simply get the value q square is actually 16 pi epsilon naught L square L minus L naught. Or better to write, q equals root of this 4 will come out 4. In fact, this L will also come out 4L. So it comes out pi epsilon naught L minus L. So this is the value of Q at the equilibrium. Means if you apply the condition of equilibrium, so you will get this value Q equals 4L under root times pi epsilon naught L minus L square. So we just saw here that we applied the concept of mechanics as well as electrostatics. So this is how the questions are, framed sometimes. So you should be having the better picture that how exactly the things are means going to apply if we have the mixed concept of mechanics as well as electrostatics. Now I told you that by conduction method, these two charges will get separated out and equally distributed because the symmetry is identical, the masses are identical, everything is identical, so that the charges will get mixed up or will get equally distributed. So as I told you that the method of conduction is very important, so you should be having a better picture about it. So let me just illustrate one more example based on the conduction. Let's say that we have three equal masses. Okay, what's happening to it? Okay. So let me say that we have three equal masses A, B, C. Initially, they have the charge. Let's say 3 coulomb. It also has 3 coulomb, and let's say it has -6 coulomb. So what exactly you are going to do is you are going to first touch A and C. Okay, like this. You are going to touch first A and C, then you are going to separate them again. Okay. Now the question comes. Okay. So what exactly will happen when you touch A and C? What exactly will happen? The charge will get redistributed. Okay. So when you touch it, so the effective charge we have is plus 3, -6. That is -3. So now, as I told you that the all three blocks or all three spheres are identical in nature and they are conducting insulated. Okay, so they do not have effect on each other because we have kept them insulated. Now, when you touch these two spheres, so the charge will be distributed like this. The total charge we have is this -3 coulomb. So it will be equally distributed. That is, half of the charge will be given to A and half of the charge will be given to C. Now what they're saying is that we are, let's say, touching now sphere B and sphere C. Okay. So in this case, the effective charge will be now -3/2. We have is on sphere C and on sphere B we have 3. So that comes out to be 3 to 6, that is 3 over 2. Fine. So this is the effective charge. So the final charge on B and C will be the half of these two. That is 3 over 4 and 3 over 4. So if we look upon the final condition, let me write it here. If we look upon the final charges on A, B, and C, we can see that A has now the charge what? -3 over 2. B has the charge 3 over 4, whereas C has the charge 3 over 4. So you just see here that the distribution has been done somewhat like this. Okay. And in this case, you can easily see that what exactly the changes have been done in the charges. So you should be very comfortable with the distribution of charges whenever the conduction takes place. Fine. Okay. Now let us take one situation here. This question was asked in JEE Advanced 2020 and it is actually very good question to build your concept. The question is somewhat like this, that they placed a spring and at one of its ends they placed a charge Q. Okay. Now what they did, they placed a dipole at the origin, okay, with some dipole moment P. The dipole is very short. So you know that the dipole is there, the charge is there, so there will be mutual repulsion between them. And due to this, this spring gets stressed. So the stressed length they gave us was L at the equilibrium. Now after that, what they did, they basically displace this charge Q by very small distance delta L, which is actually very less than L. Okay. Now you know that whenever the charge is or whenever a particle is in stable equilibrium and if you displace it by small distance, it actually oscillates. Okay. So they gave us that the oscillating frequency is 1 over delta times under root k by m and asked us that what is the value of this delta. Okay, so what exactly we have to do is this is very fundamental question. If you apply the things properly, you can easily figure it out what exactly the things are. This was the JEE Advanced 2020 question. So for that, we will be needing the electric field due to the dipole on axial position. So far we haven't discussed this, but I can assume that if you have completed this chapter, you can easily figure it out that the electric field due to the dipole on axial position is nothing but 2kp by r cube, where r is the distance of the dipole. I mean, where r is the distance of that point from the center of the dipole. Fine. So if you apply the equilibrium condition, so you can easily write that the KL, that is the restoring force, K times L of the spring must be equal to the electrostatic force of the dipole, that is Q times E. Your Q and E is 2kp by R is here L cube. Fine. So See, here you can get confused that K and K. See, this K is a spring constant, whereas this K is electrostatic constant. So let us make them different. Okay. So and now this is the equilibrium condition. Now what you are going to do is you are going to displace it by delta L distance. So in that case, your net force will be, in that case, your net force will be spring force minus this dipole force. So your spring force will be K times L plus delta L, and your electrostatic force will be this 2K dash P times Q over L plus delta L ka whole cube. So this comes out to be KL plus K delta L 2K dash PQ. And if you take out L as common, this comes out to be 1 over delta L over L cube. Now what you are going to do is you are going to shift this to the numerator, and since delta L is very less than L, so you can expand this expression binomially. So the effective expression comes out to be 2K dash PQ by L cube 1 minus 3 delta L by L. If you further solve it, this comes out KL plus K delta L minus 2K dash PQ by L cube minus 2K dash PQ by L cube times 3 delta L by L. Now, if you say that, see that this 2K dash P, uh, this cube 2K dash P by L cube can be written as KL. So you can substitute this here as well as here. So when you solve this, you get this final result as KL plus K delta L minus KL, and this comes out to be, this is actually positive. No? So when this negative comes, it comes out to be positive. So this is 3K delta L. Okay. So your net force is actually 4K delta L. So if you compare it with the standard equation, you can say that your effective K now is 4K. So you know that the time period formula is 2 pi under root m over K. So in this case, what you're going to do is you're going to write m over 4K. So which is coming out to be pi times m over K. This is your time period. So frequency, you know, frequency is 1 over time period. So you can write 1 over pi under root K by m. Now, if you compare the standard equation which was given, so you can easily predict that the delta is nothing but pi, and you can put the value of pi also 3.14. So this was the question which was asked in JEE Advanced 2020. So you can see that even the JEE advanced questions are very fundamental, very basic. If you know the things, we simply applied here the Coulomb's law, but definitely in more refined manner and in more fundamental manner. So merely looking upon the Coulomb's law, it looks very easy, but when you apply the concepts properly, you come to know that there are a lot to learn into that. So I hope this all the illustrations which I have taken is clear to you. So in the next class, we'll be dealing with some more advanced questions. Till then, take care. Bye bye.